Jon Zeolla, and how I learned to stop worrying and love vibe coding. I have no idea what that is.
All right, thank you very much. Appreciate it. So, hey everybody. Like I said, my name is Jon Zeolla. I'm one of the organizers of this event. No, I did not vote on my own CTF submission, though. So
it was all anonymous. On the CTF. Nobody had any idea.
Yep. But I am here to talk about vibe coding and really just using AI tools to write software. So welcome to my talk. It is How I Learned to Stop Worrying and Love Vibe Coding, Security Edition, because this is a security conference. So my background is I've been in cybersecurity for about 15 to 20 years. I own a couple of different companies, a consulting company and a SaaS company. I'm not here to talk about any of that sort of stuff. I'm here to talk about my mission for AI tools. And my mission is to make AI outputs three things. One, as correct as possible, as observable as possible, and as conformant as possible. And so we're going to talk a little bit about what that is. I call that the AI triad. But correct is usually like a true or false. We know if something is correct given a certain type of definition or a specification. Observable is the ability to see what is happening, so activities in the AI ecosystem, the infrastructure, the inference, right? You could think of this in the security world like an IDS, right? We want to be able to detect problems. Well, we need to see what's happening first, so logs are definitely in scope for this. And then conformance. So conformance is really, really hard. Conformance is, I think, the trickiest problem, and because it's got two parts to it. One of the parts is, what do we want it to conform to? What are the rules that we actually want it to follow? And then, is it? Right? So what do we want it to be doing? What do we want it to conform to? And then is it actually doing that? Some two pretty hard problems, but this is kind of my mission right now. This is everything that I'm spending all of my time working on. And so if you're coming to this talk, you may not know what vibe coding is. So let's go back to the origins. Andre Karpathy made a Twitter post in February. So everything in this talk is new as of this year. None of this stuff even existed last year. But Andre said, there's this new type of coding that I call vibe coding, where you fully give into the vibes, embrace exponentials, and forget that the code even exists. So the general idea is you have some sort of a conversation with an AI tool, and you say, write me some code that does whatever, right? Print me some ASCII art. And you're not going to actually read the code that gets generated. You just kind of experience it. You run it, and you see the output, and if it gives you a good vibe, you keep moving forward, right? So that's the idea of vibe coding. Does that freak anybody else out? Yeah. All right, exactly. Yeah, so kind of scary, especially in the security world, because if you think about what's the origin of these AI tools, like what was it trained on, are messy, crappy code, right? Things that have vulnerabilities and mistakes in it because it's code that other humans have written. So it can make more of those sorts of problems. And there's lots of people trying to fix this in the foundational models themselves or put guardrails in place to prevent these sort of mistakes from happening, et cetera, et cetera. But the idea is that you don't need to think as much about the code. We're going to vibe or experience or evaluate the output. And so this talk is about my kind of journey doing this a lot, thinking about and working on those sorts of guardrails and trying to think about how can we make it, because developers are going to do this anyways. People are going to, non-technical people are already vibe coding, and they're maybe the biggest adopters of this, right? It's going to happen anyways. You can't just say don't, right? So given that we can't stop it, what do we do about it? That's really what this talk is about. And so we're going to start with a quick story. So we got my friend Leo here. Leo posted a couple of things on Twitter. This was, again, just a few months ago. He said, my SaaS was built with Cursor, no handwritten code. So it's all AI, all vibe coded, and PS, yes, people pay for it. So congratulations, Leo. It's great. You're making money. You vibe coded something. Great job. But this isn't the end of the story. Guys, I'm under attack. Ever since I started to share how I built my SaaS with Cursor, random things are happening. It's maxed out on API keys. People are bypassing the subscription, creating random stuff in the database. As you know, I'm not technical, et cetera, et cetera. So he's experiencing some issues, right? Common issues if you've done vibe coding before, where it made bugs. Maybe the code is doing this. Maybe people are actually attacking him, but more likely than not, it's actually the code is just broken. Okay, so what do you do from here? Well, if you're Leo, I just vibe coded my way out of a cyber attack. Ask me anything. Right? So you just double down. Let's just keep vibing. Let's keep making changes and try to get ourselves out of this cyber attack. Let's fix the bugs, fix the issues, etc. Ultimately, it didn't work out though. I'm shutting down my app. Cursor just keeps breaking it. I can't get this thing to work. I'm trying, but it's just not working out. I can't get the results that I want. So this is a very common experience. You start and you get this kind of high, right? Right off the bat, it makes some beautiful code and it starts to look like it's working and you're using all of your vibe potential to look at the thing in the website and it's like, this is beautiful and great and I love it. But then when you actually go to run it and manage it as a production system, as something that people do pay for and expect to continue running and operate properly, things often fall apart. Here's just one other quick example of how you can use vibe coding, refactoring, right? So you might be writing giant scripts and you want to kind of break it out and make it modular and improve it. So Claude 4 refactored my whole code base in just one call. 25 tool invokes, 3,000 new lines, 12 new files, modularized everything, broke up monoliths, cleaned up spaghetti. None of it worked, but boy was it beautiful, right? So again, it is very convincing. And even if it does work, usually the way that it works is something a little bit like this. It's not operating the way that you expect. Is the water going down the pipe? Technically, yes, but I didn't expect it to look like that when I evaluate it. This is kind of what vibe-coded outputs look like. It might be working. The water is going down the pipe, through the pipe. It made it through the elbow, but it's, what happens if that flow increases or decreases? We're going to have a bigger problem. But right now, if I just went off of vibes, the water goes down the pipe and we're good, right? So when I first started thinking about this talk, I was considering, let's talk through what are the pros and cons, what are the techniques, how do we think about this, and doing it kind of like a mini training session. I wrote that talk. There were a lot of things. I could not fit it in 45 minutes. So I pivoted, I changed. Instead, what I did was I made an open source tool instead. Who loves open source tools? I love open source tools. Yeah, there we go. So I am open sourcing this morning a tool called AI Native Python. And we're gonna actually demonstrate it and we're gonna talk through it a bit. The idea is I'm gonna cover some really high level and important techniques and tools. How do you get started? How do you constrain your vibe coding to be higher quality? But if you want more, there's all kinds of cool stuff online, right? And this is really the concept. So there's this guy, Jon Zeolla. He is a AWS Lambda hero. There's like one of like 10 people in the world that are Lambda heroes. He's really, really good at AWS and serverless. And he's using AI tools just like all of us. He says, many people use AI to bootstrap projects, but the opposite approach works better. And then he goes on to explain what you really want to do is you want to set it up on the right path, a paved road. You set it on that right path, and then you use the AI tools, and more often than not, it's going to stay on the road. Right? I don't know about you, but when I drive down the road, I don't think, oh man, it'd be so much more efficient if I just went through that field. Like, even if I have to go straight and turn and go down, I'm going to stay on the paved road. It's just easier, faster, and less likely to break my car or flip it over, right? That is the same exact idea with the AI native Python paved road that I built. And so let's vibe. We are going to actually do a hands-on demonstration. We're going to do a little bit of vibe coding, hopefully, together, and we'll see what happens. It's fun. This is a kind of a crazy experiment. I give it a 50-50 chance of working. Let's do it. And if you'd like to poke at that project that I just announced, there's a quick QR code. I put my company's logo in the middle just so you can prove that it's not some random thing off the internet. You're welcome to scan that and check it out. You can also just go to GitHub AI Native Python under Zenobo.io. Okay, so can everybody see this-ish? Okay, good. 2 thumbs up, I like it. So let's do this. That's interesting. Here we go. All right, I don't know why it didn't switch screens for me, but we're going to write some Python code, right? probably a pretty common language for people to get started with, and it's going to be a pretty mature Python project. In fact, we're going to put that Python code in a container, and we're going to store that container on Docker Hub. So if you've ever done Docker run, Nginx or something like that, it's because it pulled it down from Docker Hub. And so before this talk, I made this, and you can see it's empty, right? There's no images, no tags, no nothing. And we're going to populate this thing live. Doesn't that sound fun? All right, so it exists, and there's nothing in it, though. We're going to run this one command. So if I just cheat and we go back over to here, this is that project, and you can see we have a get started. Essentially, you need to make a GitHub repository, install brew, and run these two commands, and that's what we're doing. We're running this command right here. All right, so we run this command, and we're going to make a project called BSides PGH25. So we've got to answer 11 questions. These are going to be hard, so stay with me. What's the name? What's the slug? Just hit enter again. What's the description? That's vibe. What's the company name? So Jon Zeolla. What's our company domain? JonZeolla.com. What's my GitHub org? Jon Zeolla. Who owns this? Jon Zeolla does. Okay, cool. Now a couple more technical questions. Which version of Python do we want to use? I like the newest shiny thing, so let's go with 3.13. And do we want to go to Docker Hub? By default, the answer is no, but if you want us to set all that up for you, just say yes. And is this going to be public? Yepers. And what's our license? If you pick none, which is the default, it's just going to be copyrighted. So that's the default, like if you're inside of a company or something, that's what you want. This is actually going to be an open source tool, so let's go with the MIT license. Okay, cool. So I answered a few questions, and it's doing some magic right now. We're going to see what happens in a second. But it built a project. Boom, check it out. So here's what we did. We just made two different commits. We built the initial project, and then we did our first release ever. So we've just released an open source tool in 11 questions. How cool. Now, what does this tool do? It does like 1 or 2 or like 7,000 lines of code of stuff, right? So let's take a quick look at what this thing does. We're going to just change into that directory, and we're going to look for this thing called a not implemented error. In Python, this is the standard way to put placeholders. So I wrote a project, and I made a bunch of cool stuff in that project, but I don't know what code you actually want to put in it. So I didn't write the code for you. If you want this thing to generate ASCII art or do lookups online or whatever, you have to do that next. All I did was make the road for you to go on, and you need to drive down that road. If you look for not implemented error, you will find all of the places to fill in the blank. But this has a bunch of really cool standard things. So every time you make a change in this code base, it's going to run all of these different checks, right? It's going to check if you have an HTML link, that it's actually valid, that you didn't have a typo in it, it's not 404ing. If you have JSON, that it's valid, YAML is valid. It will also check that you didn't put a secret in there, right? It uses two different tools for that, Detect AWS Secrets and Trufflehog. It spell checks. Who here has made a typo before, right? Of course, everybody. So it checks all of your markdown files for typos and a whole bunch of other stuff. You can see I'm not going to go down the whole line. Tons of really good stuff. The idea is pretty universally true. You want this stuff, right? There are other things that you might want to add that are a little bit more opinionated, and that's not built into the paved road. The paved road is the standard stuff that you want. It's the yellow lines in the middle. It's the white lines on the outside, right? So let's take a just quick look at what files exist. We have, if you've used Cursor or Windsurf or Claude or Copilot or any of those popular tools, there are these ideas of rules or instructions. We have generated and built those into this project for you. So we have Cursor rules. We have Copilot instructions right here. We've got a Claude MD file somewhere that I can't find right there, right here, and a whole bunch of other stuff. We've got software. Before we get to the software, we also have pipelines, right? Who doesn't love when computers do our work for us? So if you open a pull request, if you're going to make changes to this, we've got automatic tests and lints and checks. We've got a different set of checks for when you actually merge that code. We've got a release pipeline, which we're going to run in a second, so you can actually push things out to Docker Hub. It's literally going to be like one click. We've got security scans. We have automatic updates. Does anyone here ever run like a software composition analysis tool? or .ca, or like you look into like the vulnerabilities, the dependencies of your project. This project will automatically open. It's like self-healing. It will automatically update itself twice a week, right? So those sort of problems just like go away from the beginning. Again, once you're set on this paved road, you don't really have to think about these things. You're just always building and releasing and testing. And we've got tests, right? Tests are extremely important. And so we start with 100% coverage. You can't get better than 100%. So we're going to start with perfect. It can only go downhill from here, right? But it's going to start at like 100% full coverage. And that does a couple of things. One, it's good, right? You should just have tests. So the thing that I built for you is tested and it works. It's also an example for AI tools in the future. So when you start vibe coding in this project, it's going to look at examples of other things you've done in the past, and copycat it, right? So it's set you on the right path, and it will follow that path. All right, so you can see I've done a little bit of testing, but we're going to run this again. So this is a brand new project. Again, there's, oh, look at that. Aren't green checks beautiful? I love green checks. So all of these different things ran. There's a bunch of complexity under the hood, but check, 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 check. That's a good thing. So let's go back over, and let's cut a release. So I want to release this project. And if I go back over to here, oh, we're here. Remember that we don't have anything. We did not release anything before, but if I go back to my releases, it's running a release. All right, so you might, if you write software, you might say like, well, how does it know what to do? I'm glad you asked. So this is actually a really cool tool that looks at the name of your changes, this chore, release, or fix, or feature, if you're familiar with conventional commits. It uses the name that you attach to the different changes over time of your project, and it automatically identifies, is this a major release, a minor release, a patch release? All of that sort of stuff, you don't need to think about that anymore. I just click release. Please make a new version. It's pretty cool. So what it did actually was it determined that there was no need for a new release, right? We didn't make any changes since the last release, so cool. Don't do that. But what it is going to do is publish this Docker image to the internet. And so it's building a special version of a Docker image called a multi-platform Docker image. And that just means that you can run it on a x86 box or an ARM machine. So if you've got like an M1 Mac or an M4 Mac or whatever we're at now, or a Linux laptop or a Windows box or whatever, you can just run this and it will automatically figure out what platform you're running on and give you the correct version. So it built all of the options that are common. And if I go over here and refresh, ta-da! It worked! Yay, I love when demos work. So we have released this project. We have a latest tag, 010, etc. So like we've just done like literally a whole project that's released on Docker Hub, completely works. And let's prove that it works. So we're going to do a Docker run, -- pull always means that I'm going to actually pull it down from the internet. So there's no faking you out here. Pulls it from the internet and it runs. So we just did a basic help. We've got a verbose mode, a debug mode. We can get the version of this thing. It works out great. So okay, cool. So we've made a project. We've set the paved road. What do we do now? Well, let's pop up our buddy Claude and let's add a feature to it, right? And so let's add a cool feature to the project. Make sure it follows the existing patterns and works at the end, including documentation. All right, so who wants to bet that this is going to work? Who wants to bet that this is definitely not going to work? All right, well, let's see. Let's see what happens. It's not going off to a good start because my internet is apparently not working super well. But let's see if this is going to work out. I do need internet for this, so I might end up swapping over to my phone. Let me just see 1 minute. Come on, conference Wi-Fi, you can do it. You can do it, I believe in you. I give up on you, sorry. You didn't make it. All right, so let's open Claude again. And once we swap over to my iPhone. Oh yeah, thank you. Look at you, you're the man. Okay, so there we go. We've got some tokens. We're chugging along. I'm just gonna ignore this thing for a little bit. This is the whole purpose of vibe coding, right? Like it's just gonna figure out what to do and it's gonna do it, right? It just made a checklist. It's gonna work off the checklist. That's great. Let's find where my presentation is. There we go. All right, so while that's running, let's talk a little bit about like what's happening under the hood. Let's like maybe give you a framework for thinking about how these AIs work. And all of these AI models are trained, right? And this is what it looks like to train. Hopefully it's not going to be too loud. All right, so we're training these bots in order to walk. They're not doing so hot, right? This is essentially what it looks like at the beginning. They're not doing so hot. All right, let's jump a little bit further forward. Okay, all right, yellow. There we go. He's inching forward, make 181 epochs or iterations. That's not how I walk, but it's getting there. Let's see what these things can really do. So, all right, let's check this out. Oh, he's a pro. He's a pro. Look at this. Look at how good he is. Oh my gosh. Oh no, 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 no. Oh my gosh. Okay. Well, I mean, he made it like 20 meters. That's better. And the yellow's going down. All right. So they start by just kind of randomly jittering, right? And then they kind of progress. I don't know, a little bit about me. I love this AI stuff so much that when I'm decompressing in the evening, I essentially watch videos like this on YouTube. So this is like my evening playlist that I'm going to share with you real quick while we're vibe coding in the background. Let's go down. Now, AIs can also do some really cool things. And so, you know, Usain Bolt, super fast runner, right? Fastest in the world. And they wanted to train a bot to run faster than Usain Bolt. Let's see what this looks like. We're going to, at the beginning, okay, all right, he's walking. He's kind of doing something. It's closer to walking than we had before. But if we just want to take like a pure vibe coding approach, and again, I don't care what it looks like. I care about the results. Let's see about the results of this. Can he run faster than Usain Bolt? All right, okay, pretty impressive, right? So Usain Bolt, 9.58, that thing with his hands flying in the air and everything, 7.38. So again, if we're going off of vibes, that thing did great. It did wonderful, it's fastest in the world. Just a couple of other quick examples of how AIs might perform well, but operate under the hood differently than you might think. Let's see how AI bowls. But the results, right? The results, right? You can't argue with that. And then a final one. Let's play a little table tennis. But it's going back. I mean, I don't know. That's a volley right there. Better than I could do, maybe. Oh, okay. So this is kind of what these AI tools are doing, right? We can iterate on them and kind of improve them. They're going to operate slightly different than we expect, but they can make some interesting results. They can run faster than Usain Bolt. They can volley table tennis better than I can, etc. Just to get very briefly technical for a little bit, what we're doing here is a technique called gradient descent, or actually stochastic gradient descent. And so what that means is when we're training these models, we have this cost function. And we want to optimize the model to be best for some sort of measurement. This is conformance, right? Like we're going to measure it somehow, and we're going to optimize for that output. But like we saw in the prior examples, there's a lot of randomness involved in these systems. And so if we just simplify this down to a two-dimensional line curve, we want to get to the bottom of this line. Bottom is considered optimal. And if we do a stochastic gradient descent, you can see we're essentially like making small steps until we settle at the bottom. But that's not actually the lowest point. If I randomly started right here, going down is this way. And I keep going until I land there. But what if I had a bunch of different random starting points, which we literally do with AI tools? I start in all of these different points. Well, I'm going to converge to different minimums. This is actually the optimum minimum, but this is simple. I could just point to it and say that's the bottom. In the real world with AI, we've got over thousands of dimensions. It's not kind of this easy. And you can find how training a model, you could end up here, which is pretty good, but not the best option. And that's kind of the thing that we're contending with. Lots of randomness and difficulty understanding what's kind of like perfect conformance or optimal conformance, right? So what I'm going to do is I'm going to run through a few takeaways. If you are working at a company and your job is to help other people that are vibe coding or using AI tools, what are patterns that you should look for in their code to know that they're more on a paved road than not, right? The first one is that they have a lot of tests. So with testing software, there's actually different ways to test software. There's what's called unit tests, and that's testing like a function or a method. That's saying if I ask the code to add 1 + 1, it returns the number 2, right? It's a very simple, small, low-level test. You want to have lots of those. There's also integration tests. If I've got 3 different parts of my code base and the first one calls the second, and then it takes the answer and calls the third one, if I want to test that whole flow, that's an integration test. You want to see that. You might have end-to-end tests, smoke tests, all kinds of different things. The pattern you're looking for is that there are lots of tests, not just good coverage, but diverse scenarios and examples, right? If you're using AI tools to make the tests, there's a bit of a warning here. They love making your tests pass. They love making your tests pass. And that means that their test might be something like, I don't care about anything else that happened in this code. I just want to make sure that the log output is the right string. Literally, you said, good job, you have now completed the thing. But you're not testing any of the other variables or information. That's not a very good test. But that is what an AI tool will do if you just kind of completely leave it up to those tools. It's also really tricky. If you let, in fact, speaking of this, we're going to go over here. Oh, it's still running. We're doing good. We're making some progress. It's writing tests right now as we're speaking, actually, right? UB run pytest. There we go. It's still working. It will mask bugs in very interesting ways. So what it will do is say, you have this code and you have this test. And the test isn't passing. I'm going to try to fix the test, right? So you iterate on the test, iterate on the test, iterate on the test. And then the AI kind of convinces itself that the problem's not the test, because it would have fixed it by now, right? The problem's not the test. The problem's the code. Let's change the code to match the test. Oh, look, I got green checks. Let's move on. That's great. That's also called a production incident, right? It literally just broke your code, right? Potentially, it might have fixed your code, but it could have broke your code. And so that's something you need to keep an eye out for. It might actually go so far as to break the code in order to pass the tests. Because if you think about that local minimum, it's optimized for the green check, right? For making things pass. And it will do whatever it has control over to accomplish that. We're just going to do a couple quick check-ins on this to make sure the vibes are still going, we're flowing, it's good. I have no idea what it's building right now. This is going to be as exciting for me as it is for you. So again, back to if you are looking at a project that someone's building, how do you know that they're kind of on the paved road? They've got tests. They're enforcing things in code. So whatever it is, it's automated. They have pipelines and tests and machine-readable artifacts. If you get audited and someone says, how do you know that you always do this thing that's in your security policies? You want to be able to answer that with a dashboard, not a meeting, right? Who here loves meetings? Literally nobody. Oh, well, okay, I got one person there. All right, there you go. No, she's joking. You're pulling it back now? Okay, all right. Okay, 0, 0, 0, 0. I mean, I love a great brainstorming meeting, but if you just invite me to everything, I'm just going to start smacking no. I'm sorry. I might actually block you. Just like nobody loves being in all these meetings. We want machine-readable evidence. It's not proof, it's evidence, and we aggregate that together to tell a story, to illustrate a point, right? This is a little bit of a hot take. So if you are a software developer or write code, you've probably heard of test-driven development, or TDD, before. And that's the idea of writing the tests first, and then writing the code that passes the test, and it forces you to think about how am I going to test this thing first before you actually write the code. And that's a great idea. But things are changing a little bit with AI, and my recommendation is now a little bit different. It's not test-driven development. It's designed for deletion. We have a lot of churn with AI systems. You should expect while you're building a new feature that that feature is going to die soon. It's going to be replaced with some new thing. It is so easy to have 3 or 5 or 10 different versions of the same feature and figure out which one is slightly better and then delete the other ones, that as you're building things, you need to kind of design it for deletion. And that is very similar to TDD. You're going to have modularity and kind of isolation and things like that. But you're thinking about not how do I test this, but how do I get the whole way through the SDLC, which ends with deleting the code, right? So we're designing things for deletion. Let's do another quick check-in. I don't know why it's doing some type checking. Let's just let it keep going. You know, why not? Why not? This sounds fun. We're going to see what it does at the end. All right, so let's flip things around. That was just 3 super high-level things if you are assessing other people's code. What if you're the one using vibe coding, right? Is there anyone in here that is, I won't say vibe coding, but you're using AI tools to write code? 40% of the room. All right, so about 40% of the room is using AI tools to write code. I think that we need to automate more things in order to keep up with our developers and systems teams and things like that. We need to be writing code too, using AI tools to do that. But if you're already doing that, kind of how do you get started? How do you make sure you're doing things correctly? Well, I would say build a baseline. Something like a paved road. You're more than welcome to use the tool that I just open sourced. I think it's great. It might not fit exactly your scenario, but it can provide an example on how you can do things similarly but slightly different, right? Build that baseline. And in that baseline, if you remember, I had cursor rules, Copilot instructions, etc. Those are literally text files that explain to the AI, this is how we do things. What is my design pattern? What's my architecture? Do you run in AWS or Azure? Are you a Lambda shop, a function shop? Do you run in Kubernetes? You run on EC2s? It doesn't matter what the answer is. Putting the fact that that's the architecture you've decided on in those files is extremely important. That's where you need to start. And in my tool, it generates that for you automatically based on how I do things. And you can generate from that and change it, or you could make your own paved road. Absolutely reasonable. But that needs to be in every single repository, because each repository is different. You might run one in .NET and another in C++ and another project in Python, and they're all going to be slightly different. This is teaching the AIs to code consistently and in alignment with your design patterns. If you don't tell them, they're just going to guess. They're probably going to guess wrong. The other thing is automating code review. So we're going to fight fire with fire. AI tools generate outputs that could have issues. Great. How do I know if it has issues? Well, one option is I manually review it myself. I've only got so many hours in a day, so maybe I can't review all of it. How about we use AI tools to do review? They're very, very, very good at that. Right? And you can tweak and tune them a little bit different. You are an expert application security reviewer, and I'm giving you a code base. And I would like you to find all the security issues and quality problems and complex areas and tell me about it, right? Automate the code review. All right, to be clear, human in the loop is still required, right? We still need a person to review this code. But there's nothing wrong with a person reviewing the code and an AI reviewing the code. Right? So there are PR review bots out there that can automatically review code changes that you've made, and if we get time, we might, oh, there we go, it actually says that it's done. So we might actually show one here in a minute. So let's see how I'm on time. I'm doing okay. Let's go back to the demo real quick, because I just want to see if this thing even worked. So what does it say that it did? It explored the code base, designed a cool feature, ran the tests, linters, passed all that stuff, and updated the documentation. So, okay, great. Now what I could do, if my hands are on the right, I could look at all of the code that it just wrote, and this is all of the code that it just wrote. I have to go faster because there's a lot of it. Or we could just do git checkout-b vibe coding. Feature vibe, make some kind of new cool thing. I have no idea what it is. All right, cool. So look at what happened. So the AI generated a bunch of code, and there were a couple of things that failed. But let's do this and go back to commit again, and it automatically fixed most of, oh, actually all of those. So the paved road has a thing called pre-commit auto fixers. It just fixed the AI's code in like 4 seconds. And I've never even seen this code before. I have no idea what it did, but it fixed it to whatever my requirements were. Cool. Let's do a push. And I have no idea what this is. It's just vibe coded. Fingers crossed. Oh, that's not fingers crossed. This one. All right, did we validate the documentation is accurate? No, we did not. Did we do manual testing? It didn't tell me that, so I think we're good there. And I'll have to see if there's any dependencies. So that's my little checklist, which again is built into the paved road. Let's open a pull request. And there we go, 656 lines of new code, 24, and boom. All right, so what is it doing now? Well, it's running security scans, code validation tests. It's building it on multiple different platforms. It's doing a bunch of really cool stuff. If I go over here and just do a quick task build, I can build this Docker image myself locally. And there we go. And let's just see how to use this thing. We're going to go down here. And is that how it's supposed to work? Let's do this. Oh, look at that. We got all kinds of new stuff. All right, so let's do like a vibe type pattern. What else do I need to do? I need some vibes. I need to add some vibes. Generate a vibe. EPC 1, 2, 3, I don't know what it wants. What do you want from me? There we go. Vibe. Oh, cool. CyberSec Pittsburgh 2025 with a cool little lock thing there. Network secured vibes amplified. All right, cool, man. I mean, you might be going off the deep end a little bit here, but like, all right, I gotcha. So cool. We made like, I don't know, some sort of cool continuous. What does continuous do? Continuous. Oh, wow, BSides, look at that. Look, oh, there's another one. Firewall activated, bad vibes. That's vibe. Okay, cool, like this is valuable to me. Like I need this. I didn't know I was missing it until I saw this. Okay, great. Cool, so let's go over here. Oh, look at that. So we've got lots of things checking and passing it for all kinds of different things. But I've also got an automated PR review bot taking a look. So it's taking a look. Let's see if I give it another minute or so. It might give me some findings. We'll come back to this in a minute. All right, let's see if I can get to my presentation. All right, so a quick aside there, we just like vibed some code and it's running tons of tests. It auto-fixed itself. It's validating and maybe we'll build, deploy, and have this thing on Docker Hub by the end of this talk, which is in 3 minutes or maybe 10 minutes. There, 10 minutes, like according to, thank you, Scott. So automate code review, fight fire with fire. What you just saw, that comment, looking at it, that's an AI bot that's reviewing the code that I opened a pull request for, and it might find some issues. And it's going to be very different than the automated find and fix pre-commit tests and linters and checkers that I have built in. It's part of this like ecosystem or suite of solutions. Another very important thing is to treat requirements like code. If you have ever had a meeting and told a developer or a systems person, you must do X, Y, and Z, that's great. But can we codify that? What exactly does it mean to do that? And how do we apply that to this given, hi Sasha. How does that work for this scenario? Additionally, when you say you must always do this thing, we want to be able to ship that to all of the places where it matters. All of the developers in my company that need to follow that requirement, they should all know that, right? It's not a secret. They don't need to have a special meeting with me to know this. Like, we should disseminate this information. So how do we do that? We treat it like data. We treat it like a database. So how do we change the way we manage requirements so that we can ship them with lots of small, fast changes, quick approvals, peer review, and very importantly, we know why. If this is a requirement, I gave a whole series of talks on this. You might have requirements that are because if you don't do it, someone at your company goes to jail. Please do those, right? You might have a requirement because a contract says it, one of your customers says it. That's very important, but you have more options. You can cancel the contract, right? You could stop working with that customer. That's on the table. That is an option. Probably not the option you'll take, but it's a possible option. There are also things that guy said once in some meeting that they claimed was a requirement, and that's cool, but if that thing costs us $50 million, we might decide not to do it. But if that thing costs us $50 million, but someone's gonna go to jail, we're either gonna exit that business or do that requirement, right? Like it's a very, how you decide depends on why it's a requirement in the first place. So have tests, have ways to store and transmit and share this information, practice these, and treat it like code. Get peer review, have context, background, figure out why. And so we want to change these requirements, whatever they are, policies, contracts, engineering or requirements, design documents. Find ways to make those machine readable context. There's tons of different ways you can do this. Make it a structured text file, make a CSV file, make a graph database or a SQL database. There's a bunch of solutions to the problem, but do it. I highly recommend to do it. Also, if you're doing this yourself, there's this thing called MCP, right? Model Context Protocol. And this is extremely powerful to augment the AI while you're writing the code on your laptop, right? So use it, right? Use these tools. Don't use it without company permission, but you advocate for using these tools. There are security tools and checks and validations that can be done as the AI is writing the code. So think about, write a super cool feature. What if it was getting checked by an AI as it was writing? There's two different AIs, and one's job is to write the thing that you asked for, and another AI's job is to make sure the first AI isn't messing up, right? Not going to be perfect, but is your quality bar going to be higher? Absolutely. Right? And then this new technique called specification-driven development. Remember TDD, test-driven development, write the tests first and then pass them? Spec-driven development says, write a specification, let the AI match the specification and ensure that it's conformant with whatever your requirements are, and then validate, 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 right? So fingers crossed. Let's see, how is this thing doing over here? Let's see, can we go to the top? Do we have a pull request? Oh, green checks, boom. All right, ship it, because why not? Done. Okay, cool. So I merged that request. We are running more checks in this pipeline, but I'm pretty confident. Let's just do a release. All right, so let's see what happens here. So we're going to release this feature to the world. You can all use it on your computers in a few minutes if you'd like. We're going to first, again, automatically figure out what this is. Is it a major change, a minor change, etc.? Let's see what our magical tool tells us. It is going to be based off of this feature, so my guess is going to be 0.2.0, and it is. Look at that. So it automatically figured out this is 0.2.0, and now it's working on publishing that thing. So it is, if I go back over to my terminal, we're going to do 0.2.0, and then we're going to add a -- pull always. That will make sure it actually comes from the internet, so there's no faking. And we're going to do the exact same vibe type pattern, vibe continuous, etc. Let's wait for this thing to finish. This is going to take a minute or two, so I'll go back to the slides, and then we'll polish this off and be able to pull this thing from the internet and run it. I just need to get back to my presentation, which I don't know where it went. Here we go. I'm going to call it success. We did it! Congratulations, woohoo! We were able to vibe code something, and it worked. Just in case, though, I promise it worked last time, but we don't have to say that. It actually worked. So there's a lot of hard problems. We have to kind of wrap up. We're out of time. But there's a lot of hard problems, which is like, what are your requirements? If you have more than one person at your company, it's probably hard to know exactly what's a requirement and why. I'm a huge fan of knowledge graphs or graph databases for this. You can create essentially something that looks like this. How do we distill all of these different documents and requirements and things, extract the entities, build relationships, and traverse a graph and know why? Why does this matter? What is its origin? Where did this thing come from? So I'm a huge fan of knowledge graphs for that. But in a real company, your knowledge graph is probably going to look a little something like this, right? It's going to be a tangled web, a mess. And so what do I recommend? Get started, right? We're all going to have to contend with this mess of data and mess of requirements. We don't know why, because it was never written down. And that person who decided doesn't even work here anymore. And it might be required for a contract that hasn't existed for a decade. Start untangling the web, because as we're using AI tools, we need to have this really solid foundation of why. What are our requirements and why? And then how do we start to follow them? So if you want more, here's a bunch of resources. SANS just released a Sec 545 class. It's been selling out like hot. It's been selling like crazy. 3 blue, 1 brown or latent space are great if you want to dig a lot deeper. OWASP has great resources. DEF CON has AI Village. And then, as always, you can just ask. I'll be around all day. I'm happy to talk about this stuff. I'm pretty much addicted to it. So I'm happy to talk about it. Let's jump back over here, see if our release finished. It did. And is it going to work? It's pulling, it's pulling, it's pulling. Ta-da! There we go. All right, so the whole thing worked end to end. We vibe coded something, shipped it to production, released it, and I'm now running it on my laptop. You're all welcome for my wonderful contribution back to this community. All right, that's it. We are out of time for questions, but what I'm going to do is I'm going to hang around over here for the next however long people want to talk for. Feel free to come up, say hi, ask questions. Thank you all for your time. Hope you had a good time. Oh yeah, and feel free to send me a message on LinkedIn if you're interested.